Actually, you guys have a lot more food than Sable does.
Dude, they have McDonald's this morning.
You're kidding.
Yeah, we had Happy Meals.
Chicken nuggets?
We
Yeah,
had a round of
welcome to
cheeseburgers,
ECB.
And then we had a round of
Fucked up.
Hello, testing. Okay. Alright, hi guys. Welcome to Lightning Talks. Thank you guys so much for coming out. We have a handful of presenters presenting tonight. Our first presenter is Spencer. And if you guys stick around for all of the presentations, even after you've done your presentation, you know, I'm sure other presenters would like to have, you know, just as much of an audience as you did. We will also have like Q&A after every presentation. I'm not really enforcing any time limit. I know if you got my email, it should be like 5 to 10 minutes, but we do only have like a handful of presenters going on tonight, so go on as long as you want, you know? So, all right, let's kick this off with Spencer.
Everybody hear me? Pretty small, everyone, when you do this. So I was not aware of the time. I thought we were going to have more of a time limit, but okay. So hello everybody, my name is Spencer Fricky. I'm going to be talking to you guys today about GPUs and the life of the pixels. Quick warning, I'm going to be coming to you guys at supersonic speed. This is your only warning, so please pay attention for the next 5 minutes very closely. So what is a GPU? A GPU is a graphics processing unit. It's a separate piece of hardware designed to do graphics. You can use your CPU. If you do, you're going to have a bad time with integrated graphics. Don't do it. You need GPUs. You have a lot of vertices. You got to move them. You got a lot of them. The problem is now you have to do it at 90 FPS. You only got like 16 or 11 milliseconds to do each frame. And the problem is you have all these transformation matrices, and your CPU can only do one at a time, but your GPU can do thousands at a time. The moral story is GPUs are designed parallel. So now, this is why GPUs are used for things like neural network, Bitcoin mining, because they can do all this stuff in parallel. And they're also really used for graphics because a 1080 screen, that's 2 million pixels. That's a lot of pixels to have to push out every 16 milliseconds. So now we have VR, you double the screen so you have to render, so that makes it even harder. With AR, you take the live camera feed and then have to display it over, so making it even more computationally heavy. Now, you have this kind of architecture you're probably used to. You have a CPU, RAM, hard drive, you pile code for your CPU, and that's how you communicate. But now you have this separate piece of hardware. How do you get to program this? And this is where GPU APIs come in. Pretty much is a way for your CPU to tell your GPU what to do. And the lucky thing that I always joke how wouldn't it suck if all the ink cartridges had ink cartridges were different? Well, they are, and it sucks. So now imagine with these 5 hardware companies, they all have different ways to talk to their GPUs. It'd be terrible. So this is where the Cronus Group comes in. The Cronus Group comes and makes all these great standards, and they're endorsed by all the tech billion-dollar companies. So the whole idea is you write your program once, and the functions work on every GPU the same. So this is really convenient. You use things like OpenGL. OpenGL has been around for about 25 years. You have C++ headers. Instead of functions, there's OpenGL ES, which is an embedded system version, subset, designed for lower power things like phones and tablets. If you want to be a web dev, totally fine. There's web browsers who use WebGL, and WebGL calls OpenGL ES underneath for you. This way you can still talk to your graphics card doing web dev. The best part is that with like 98% coverage, you can access the entire world using WebGL. So Vulkan's a new player in the block. Apple has their own thing for iOS phones, and Microsoft has to do their own thing as well because it's Microsoft. Quick plug, Vulkan is the first open source graphics API that was pretty notable for this hackathon. Abstraction levels. You can do everything you want in Vulkan. I've done it before. It's 1,500 lines of code for a single triangle. It's miserable. Seriously, look it up. OpenGL ES give you a little bit more leeway. There's really great frameworks like 3GS and Cinder, which then do a lot of stuff for you. But if you use things like Unity and Unreal Engine, these things are really powerful tools that you make really cool applications in a matter of hours. So it's kind of a trade-off between do you want full control or do you want things to be done easier. So this is the life of the pixels. This is everything that goes into a graphics API. This is very overwhelming, so I don't expect anybody to understand this. I've been doing this for like 2 years. It's still confusing to me sometimes. But we kind of got to hurry up because, yeah, we only have so much time left to get that pixel out. So the first thing you got to do is decide what GPU you want. You might have multiple GPUs in your system. So first you got to pick that GPU. Then you got to decide what screen to render to. You might have one screen, dual screen, 16 screens. You don't know. So then you have the swap change. You have one screen you can render it on, but you have 2 in the background being drawn on. So that way you can have up to 2 or 3 things being drawn at once where they get swapped out. This way, this is how you get efficient things. And if they don't get in the right sync, this is how you get screen tears. So everything's based off these image views, which are 2D allocations of memory. You need them for a lot of things like frame buffers. So you have a lot of frame buffers. You have a depth frame buffer, a velocity frame buffer, a specular frame buffer, etc. And these are broken into layers, and those layers then have to get compounded into multiple render passes, and this is what, so there's a lot of things that go into a single frame. And the worst part is it's all asynchronous. So if you've ever done anything with like threading and stuff, you know how asynchronous stuff gets really awful. So yeah, you gotta do all asynchronous as well. And so here's the basic scene. We got the blender monkey and a ball. So we take the first thing you gotta do is get geometry. So this geometry, you gotta have all the vertices there to make up the geometry. And then you have to know what order they display them at. So these three are the same thing, but depending on what order you put them in, one thing gets up in front of the other. So you gotta allocate memory for that too, so you have to know what thing's in front of the other stuff. Then you have the color has to be allocated, you gotta have each color allocated in memory. Don't forget the normals, when the light bounces off, you know which way the light will bounce off, so you gotta allocate memory for all the normals. And the worst part, we only have 16 milliseconds, you gotta hurry up guys. So you have textures, memory for that too. You have shaders. Shaders are separate programs you build for your GPU. You compile them and they run on your GPU. Don't forget you gotta allocate all the memory for those arguments and everything. So now we can finally send data to our GPU. Awesome. So the first thing we do is run it through our vertex shader. We essentially take all the vertices we have, put it down through the vertex shader, and get placement for them. And using the depth buffer and everything, we rasterize it. So now we can put up each pixel, the pixels to each pixel on the screen. And then you put that through the fragment shader, and taking things like the color you gave, the image you gave, the lighting you gave, you finally get a final color. And with all that, you get with a lot more magic, you finally get your final scene. We did it. We got a scene. We got one frame out, guys. Now we only have 16 more milliseconds to get the next one up. You gotta hurry up. Thank you.
Alright, that truly was a lightning talk. Alright, we do have a second presenter, I believe. Checking that presentation.
Yes.
Is it working? This computer's off, so I can't test it.
What? Why not?
Test, test.
We put it on Kevin's
Yes.
phone.
So I'm going to be the first to admit I'm not going to go as fast as that man before me. That was really impressive. I think he woke everybody up. I am not that man. Life goals though. Dev, Yomi, come on, walk in. Come on, I see you. Some Bitcoin can't lure you away this time.
Forgot to mention this earlier. Be sure to say hello to the camera in the back. We are actually live streaming these lightning talks.
Hey YouTube. There we go. All right. Alrighty. Okay, so hey everybody. Good morning. Welcome to 2 a.m. hackathons, all of the fun things. I'm going to be talking about documentation and inclusion. We do a lot of open source stuff here at Hackillinois. I'm not part of the team. I'm just saying that. But a big part of making an open source project is documentation and inclusion. You want people to be a part of your project, and to do that, you need to document it. Now, shout out to myself. There's a Twitter handle there. If you want to tweet at me, complain about my slide deck, do it. Challenge you. All right. So, first of all, I want to talk about READMEs. READMEs are like ground zero for a project. Everybody's seen a README who's used an open source project. You pull it up, it's the first thing you see. And you know, within 3 seconds, how much effort someone put into documenting that project. You know, it's going to be good or bad. And we're going to walk through what makes a good README, what makes a bad README. So a good README, really, you've got 3 core objectives. You want to explain what the app is, you want to explain how the app works, and explain how someone who's coming into this project can help you. Why should they contribute? So let's start with the bad example. Let's look at the ugly. So this is a project I worked on. It's called Tweachable. It is a civic technology project. It's a Twitter bot. This was our README like a year ago. There are tons and tons of code blocks. There's like URLs everywhere, but none of them are hyperlinks, so you have to like copy paste everything into your browser. It's not organized. You can't like, how are you going to find anything? So it's just, to be frank, kind of flaming hot garbage. It's not really useful. You can't really tell what is going on. This is a README of another project. This one was a website for a studio that I'm a part of, and our README said nothing. It didn't list our technologies. It was useless. Our own team members didn't know what our site was made in, because this whole thing, all 3 lines, were our README. Really doesn't cover any of the points I mentioned. So let's go away from the ugly for a bit and let's take a look at some great READMEs. So this is our revised README from Teachable. We shortened it down, we made it super easy to understand, we list the tech stack, learning more, how you can contribute. We link to a bunch of useful things like our working group, the Getting Started guide, Code of Conduct, which is also a really big part of an open source project. That really helps someone get involved. This, who's heard of Bower? Raise of hands real quick. All right, good number of people. Bower is a great, great system. And they have this wonderful bird there. That tells me they care. But, among other things, they have great installation instructions. Right there, npm install-g Bower, you know how to get going. And it also tells you about contributing right there on the second part of the slide. So you know right away, how do I help? What does this do? Why do I care? All right, code documentation. All right, fuck the microphone. No, I don't know if the camera is going to need it, so we're just going to hold off to this, like some weirdo. So code documentation is one of the most underrated parts of hackathons. I can't blame you. You're on coffee. You've got 2 hours of sleep. But when you're working on an open source project, it's really important that you document your code. And why does it help? The reason is people shouldn't need you to work on your project. If you're making it open source, and I need to constantly pester you to be like, hey man, what does var a do? It's like, what? That is not doing your job. If you want people to help out your project, you need to document it. You need to make it clear what everything does so that they can help you, they can understand your work, and they can make it better. So it's your responsibility to make sure you document your code, and also that you enforce documentation as a big part of your pull requests, your general practice on an open source project. So, contributors are more comfortable if they can learn by themselves and not feel like a burden. This was a huge thing we saw with Teachable, a huge thing I see in all of my work with open source projects. People feel like shit if they're constantly asking you for help, constantly badgering you. If they have to ask you about everything, they feel like they're a burden on your project and they're not helping you. So you need to empower them to work on your project and to feel like they are doing something for you. Project leads don't feel wore down explaining basics repeatedly. Before we updated our README with Teachable, I went through the same installation instructions time and time again because no one could figure out how to install our project. You don't want to do that, especially if your project goes big, you can't explain to everybody, and if they can't figure it out by themselves, then you're going to get really burnt out really quickly, and nobody's going to use your project. So this is really the main idea. Open source is not just about open code. Everybody can make a public repository on GitHub, but that isn't what makes open source special. Open source is about communication, it's about making it so other people can work with you. And you need to open that up by documenting your code, documenting your project, and putting all that effort in so that other people can help you. And it's about removing and lowering barriers of entry. People shouldn't need a PhD in computer science to understand your code, and they shouldn't need to know you personally to understand your code or to be able to figure out how your project works. You need to make it so that other people who don't know you, haven't heard of your project, can help you and learn what to do. So, lastly, who am I to tell you this? I'm Victor. I'm a front-end engineer at pac-man. We're a startup in Chicago, and I make websites for a living, games for fun. But I do a lot of group programming, pair programming, open source work, and documentation is the thing I am really nitpicky about. I enforce it everywhere. I'm the guy who's on your pull request like, hey, there's 2 lines that don't have a comment here. You're not getting this through. I'm like that annoying guy. That's me. And there's a reason for that, because it makes code better, and it makes it so that other people can contribute to your project. So, with that said, thank you for your time, and enjoy the rest of your morning. Yeah.
No, you're that way. How Oh no, I did it like that for a reason. You just like,
Oh, hell yeah.
Hello.
Yeah, Davey is our third lightning talk presenter.
Alright, so Tider is if you've seen, I posted it in a few places, but I'm on 3 hours of sleep, so this is gonna be interesting. But essentially, what if you could match with someone based on their personality versus just say spending 1 or 2 seconds looking at their face and being like, damn, like this chick's hot, or like, damn, this guy's hot, and then swiping left or right. So what if you would look at them and look at their personality? And so, this side is like apparently, wait. Okay, so I guess I forgot the side. The situation is, so you have current dating apps like Tinder and Bumble, and they're really superficial, right? So you spend 1 or 2 seconds, you determine whether or not someone's attractive, and then you swipe left or right. And it's really informal and really ingenuine. And so we're working on revolutionizing that. So the solution is to revolutionize the dating industry to let you match with people based on customizable Tide Pods. It sounds stupid, but it works. So you match, so because part of your personality shows through how you customize your Tide Pod, so you give your Tide Pod a name, a tagline, a description, and 2 captions, and you can, and like the surface of the Tide Pod can actually be printed on, so you can actually put ink on a Tide Pod. I'd actually researched this, like I had to actually like find like what a Tide Pod is made out of, surprisingly. And apparently the surface you can actually like print on it, so you can customize it. And part of the business model is like you can like send your friend like a prank Tide Pod, and the other part is obviously matching with people based on customizable Tide Pods. So we started this development at Uncommon Hacks at U Chicago, actually in Illinois as well. So this is our website that is actually live on the repo. So if you go to repo, you can actually like, if you clone it and you run React on it, you can actually pull this up on your computer. And so it's basically you hit 3 areas. One is social, one is economical, and one is environmental. So social, obviously you're meeting with people. Economical because like not only Tide can sponsor with Tide Pods, you can also have say like Charmin toilet paper. You can have like your friend's face on like toilet paper, or like you would wipe your butt with like $100 bill. I don't know, like whatever you want. And then environmental is like because laundry products use water, toilet paper uses trees. There be reminders embedded throughout the thing. So when you match with someone, it's like congratulations, you have a match, and it's like be sure to save water when you're using the toilet or something. I don't even know. We just like came up with that because we needed 3 things. It was like the rule of 3s. So yeah, we have environmental in there. Yeah, and so we have a bit of personality in all our products. And so this is a picture from the hackathon. So we actually had to draw wireframes. So you can see like the UI that we drew out on like whiteboard. That is actually part of the implementation. I haven't pushed all my commits to the repo yet. But essentially, you can see like the social, economical, environmental, and then also just how the UI works, kind of like Tinder, but you can customize your own Tide Pod. And our punchline was love at first bite. Based on the recent epidemic with Tide Pods. So that was interesting. So timeline is, so I'm actually trying to like finish this thing because we got like 80% of the front end done and then like 70% of the back end done. And so I actually want to like make this an actual product and put it on like the Play Store. And like I'm still trying to find like a random meeting to like just like mess around with this. And so hopefully by April, and then you can actually see the repo at Tider _ 2.0 because the first Tider repo is from just Uncommon Hacks. And then I have some other projects on here. And so it's more info, so yeah. But
Coach. All right.
Oh, I the order doesn't matter, but
So as a show of hands, who still wants to present? Or we have one, two, I think there's a third somewhere. All right, yeah. Either one of you guys.
that's gonna be for my app, right?
And if you email me your slide. One more thing, even as you guys are sitting and I guess like listening on your computers, maybe in the back of your minds, if you guys have like an idea for a lightning talk that you want to give, just like right on the spot, really impromptu, go for it. We do have a lot of time still left in this lightning talk session. It can be really on anything. Of course, keep it clean. You know, we have YouTube watching in the back. I'm sure there are kids on the stream. So really anything. Yeah, with that, we do have our next presenter.
Does it pick up back there, or? Where is it?
You might want to run and get it.
Done with the meetings. Alright, you gonna do it, or?
Yeah, I mean.
Oh my god. Alright, hi there, I'm Josh. To be honest, I'm really tired. I can barely focus on what's going on right now because of how little sleep I have. But I'll try giving you guys a great talk on React to Firebase. But first, I'll tell you about myself. My name is Josh. I go to Indiana University studying computer engineering. In my free time, I like to dance. And yeah, what is React? React is a framework that was created in 2011 by Jordan Wackey at Facebook. It was a way to loosen up their typing couple front end. It's a mix of using HTML markup inside the JavaScript, which was kind of controversial at the time. It was inspired by some PHP libraries, and the reason that they made it into a React framework is Instagram saw what Facebook was doing and was just acquired by Facebook and wanted to use that framework as well. Here's an example of a small React app. It's only one line, so you have the HTML text that you want to render, and then you have some div or something with an identifier with the name group. React uses a virtual DOM, which is a document object model. What the DOM is the way to it renders your content to the page, but instead of using the real DOM, which is really slow, they have their abstraction on top of it so that they can render sometimes really fast without having all the actual DOM. It's a declarative language. You just kind of tell React how you want to do things, and it'll figure out the best way to do that the most effectively and with the most tightest time complexity. How React knows what components to render and non-render. It has a diff tree, so it will look through all the components and see which ones have changed based on the given state. And so you can actually force this yourself. There's methods inside of React that if you wanted to re-render for a certain condition, you can. And React offers a one-way data flow. So if you have a component and you pass some state to a component below it, that state becomes props, and props are immutable in React. So my next part of this talk is Firebase. Firebase was founded by James Tambin and Andrew Lee in 2011. It was a very busy year in 2011, apparently. It's a web-based solution that you can use for authentication. It's a NoSQL database. What that means by NoSQL is it's JSON objects, so it's all JavaScript-based objects. Yeah, and it offers storage, static hosting, and functions. I really like it because it's just super easy to get into. Once you get it, it's just great, and you don't have to worry about hosting or anything. It runs on almost anything. It runs client side on your computer. You can actually, this is the config from my website. If you try to take this, you're not going to be able to get to my website, so I dare you to. But yeah, it's pretty secure. You can set database access on certain conditions if the user's logged in, or permissions, or give rewrite access to portion your database. And it's, yeah, like I said, it's very user friendly, and the documentation is really good, right? So how I use React and Firebase. So since React is